Well, students, yesterday I told how the carboxylic acids, that is monocarboxylic acids, are prepared. As told about the three methods, I explained the three methods. One is from alcohols. So, from alcohols or from aldehydes already were studied. The oxidation of primary alcohol gives aldehyde, which on further oxidation gives carboxylic acid contain same number of carbon atoms. Even carboxylic acid can also be obtained from secondary alcohol, but ketone formed is not easily undergo oxidation as we know because of the two bulky group attached to the carbonyl group. Then whatever the secondary alcohol used, the product formed contains, the carboxylic acid formed contains less number of the carbon atoms. So best method is by using primary alcohol and aldehydes. We can also prepare the carboxylic acids from nitriles and also from the carbon dioxide using Grignard reagent. So let me explain the preparation of carboxylic acid in detail. Now first one is from alcohols. Or is bar in the right aldehyde. Well, primary alcohols, or I am writing 1 degree alcohols, 1 degree alcohols on oxidation with acidified K2Cr27, acidified K2Cr27 gives aldehyde, which further undergo oxidation, to give carboxylic acid. So we know general formula for primary alcohol or 1 degree alcohol is RCH2OH. It is 1 degree alcohol. So this is on oxidation with acidified potassium dichromate. So nascent oxygen written in the square bracket or simple bracket means it is produced by some oxidizing agent like Cr27H plus. Okay, the product formed is aldehyde. Aldehyde formed further undergo oxidation by Cr27, that is K2Cr27 bar H plus to give carboxylic acid. It's more stable compared to aldehyde. So we can get carboxylic acid from 1 degree alcohol. 1 degree alcohol. A simple example is ethanol or ethyl alcohol. We know the formula for ethyl alcohol CH3CH2OH. It is ethanol. So it undergo oxidation with acidified sodium dichromate or potassium dichromate. In general, we can write Cr27 2 minus bar H plus gives CH3 CHO, acetaldehyde. So acetaldehyde further undergo oxidation to give the product CH3COOH. We know this is called ethanoic acid or acetic acid according to common system. According to IUPAC, ethanoic acid, and we know this one is ethanol or star. Second example, it's aromatic alcohol, CH2OH, and this aromatic alcohol is called benzyl alcohol. So benzyl alcohol on oxidation, usually you are using strong oxidizing agent, or even K2Cr2 7 can also be used, but little good oxidizing agent like KMnO4 is used for this one, because we have side chain oxidation. Use benzaldehyde. So benzaldehyde further undergo oxidation to give benzoic acid. Benzoic acid, COOH. This is from alcohols or aldehydes. We know alcohols on oxidation to aldehyde, or if it started with aldehyde itself, then it gives the directly carboxylic acid. If it started with alcohols, then aldehyde is formed, which further oxidizes to carboxylic acid. Second method is from nitrile. We know the formula for nitrile, CN, RCN. So here you have to convert RCN into RCOOH. But actually the direct conversion do not take place. You have to hydrolyze it. On hydrolysis, at first you are getting amine RCONH2. Afterwards, which on heating gives the carboxylic acid. So you may say it is from nitrile or amine. So it is one of the best method. Use it to prepare carboxylic acid. So here carboxylic acid on hydrolysis, generally you are using acidic medium. So acid hydrolysis of carboxylic acid gives amine, which further undergo hydrolysis to give the carboxylic acid. Nitrile on hydrolysis gives amide, which further undergo hydrolysis, or which further hydrolyzed to carboxylic acid. Carboxylic acid. So formula for nitrile is RC triple bond N, or RCN also you are writing. Undergo hydrolysis in presence of acid, mineral acid like HCl, or maybe dilute H2SO4. The product formed is RCONH2. So this RCONH2 further undergo hydrolysis in acid medium. So on heating, usually you have to heat this amide. This is amide. Product formed is RCOOH. So RCOOH plus we have NH3 or NH4 plus. So example, or it is NH4 plus, I am writing, or NH4 example is CH3Cl. Number of carbon atoms are 2, so it is ethane nitrile. Ethane nitrile. We know the common name of CN is cyanide. So whenever you are naming the CN compounds as cyanide, then this carbon is not considered. The C of CN is not considered. Remaining carbons are considered. So it is methyl. Then it is cyanide. We know CH3 methyl cyanide. Methyl cyanide. Common. Plus H2O in presence of H plus. The product is CH3 CO NH2. It is acetamide. Acetamide. Acetamide further undergo hydrolysis to give acetic acid CH3 COOH. Product is acetic acid. Second example, so common name for this one is like methyl cyanide. So we know C6H5. This benzene ring is C6H5 with one nitrogen less. Phenyl, C6H5 is called phenyl. Then cyanide. IUPAC name is, it is called benzo. This one is called benzo. This one, other than nitrogen. So it's a benzo nitrile. Common name is phenyl cyanide. Phenyl cyanide plus H2O. It undergo hydrolysis to give amide. The product formed is benzamide. CO and H2. It is benzamide. So benzamide undergo hydrolysis to give benzoic acid. Benzoic acid. So in the preparation of carboxylic acid from nitrile, it involves two steps. Nitrile is converted into amide, then amide into carboxylic acid. So example are ethane nitrile or methyl cyanide, amide is acetamide. So benzonitrile or phenyl cyanide, amide is benzamide, product form is benzamide, which on hydrolysis gives the benzoic acid. Now next method, number 3. Third method is from alkyl benzene. It may be toluene or it may be ethyl benzene, whatever it may be. Number 3, alkyl benzene. Alkyl benzene. So here, whatever that alkyl group it may be methyl, ethyl, propyl, isopropyl, whatever it may be. That alkyl group is oxidized to give carboxylic acid. That means whatever the number of the carbon atom in the alkyl, so finally you are getting COH in that instead of that large number of the carbon, one COH. All other carbons are oxidized to carbon dioxide or some other compounds. That means any alkyl group attached to benzene on oxidation using powerful oxidizing agent like alkaline KMnO4 gives the benzoic acid. So, oxidation of from alkyl, oxidation of alkyl benzene with strong oxidizing agent, strong oxidizing agent like alkaline KMnO4 gives benzoic acid. Benzoic acid. Example, toluene. It may be ethyl benzene also, it may be propyl benzene. Product is benzoic acid. Whatever the carbon numbers in alkyl group, but final product is benzoic acid itself. So I am writing toluene here, CH3. It's toluene. On oxidation with alkaline KMnO4, means KMnO4 is mixed with usually sodium carbonate instead of sodium hydroxide. Sodium carbonate you are mixing and it's refluxed, heated strongly. It's refluxed. The product formed is benzoic acid. Benzoic acid. Again I am repeating. It is not necessary it must be CH3. It may be C2H5 or C3H7 or whatever it may be, whatever the number of carbon atoms, final product is benzoic acid. Number 4. Using Grignard reagent. By using Grignard reagent. Grignard reagent or from carbon dioxide. So we can prepare carboxylic acid using Grignard reagent or carbon dioxide. But in this case, carbon dioxide is bubbled or passed. Even sometimes you are using dry ice. Dry ice is nothing but CO2 in the solid form. To that solid form CO2 or gas you are passing, the Grignard reagent, ethereal Grignard reagent is added. Addition product is formed, which is hydrolyzed to give the carboxylic acid. Okay, so sentence is Grignard reagent on treating with CO2, we can write dry ice also, don't get confused. Use addition product. Addition product which on hydrolysis gives carboxylic acid. Gives carboxylic acid. So here I am writing general formula. We know Grignard reagent RMgX plus carbon dioxide C double bond O. In this form I am writing. As we know, it is electronegative. The electron pair move towards the side. It's positively charged. This carbon become positively charged, as already was studied. This R is Now it is negatively charged, Mg carry positive, this one carry negative. So this negatively charged are attack on this carbon, positive charge of carbon, and this MgX attached to this oxygen. So product is in the examination, no need to show this arrow mark. If you are perfect in this, then you can show the arrow mark while writing the answer in the examination. Otherwise, no need. Directly you can write the. Sometimes what happens, students get confused is to write R to this one and Mg to this one. So no need to show the arrow mark. If you are perfect in that, then you may show. Otherwise, no need. So here you are getting R. C, this double bond O is not affected. Then Mg attached to this one, this oxygen, O MgX. So it is addition product. Now this undergo hydrolysis in presence of C. You R C double bond O OH or plus this Mg, then we have X and OH, or we can also write this one as R C double bond O OH. So examples. Example, you have to complete this one at home. Number 1, CH3 Mg Cl plus C double bond O double bond O. You have to complete this one at home. Second example, number 2, C2H5 MgBr plus C double bond O double bond O. This one also you have to complete at home. So general equation we know. With the help of general equation, you can write the equations with the Grignard reagent, methyl magnesium chloride, and second one ethyl magnesium bromide. Okay, so after this, it is from esters. Number 5 from esters. Esters. Well, the general formula for ester is RC double bond O, then O R dash, or it's RCOOR dash. Already we are studied in alcohols. Esters are formed by the reaction of carboxylic acid with alcohol in presence of concentrated H2SO4. So that reaction is reversible. Which one? Reaction of the alcohol with the carboxylic acid to be ester is reversible. So what happens? The product formed are, it's a ester and water. Reactant are carboxylic acid and alcohol. So alcohol react with carboxylic acid to give the ester plus H2. It's a reversible. That means here one more possibility, that ester undergo hydrolysis to give the carboxylic acid and alcohol. Well, here you are using two mediums. Mediums means two conditions. One is by using the acidic medium and second one is by using alkaline medium. So when you are using acidic medium, the product forms are carboxylic acid and alcohol. And when you are using alkaline medium or basic medium, the product formed is sodium salt of carboxylic acid and alcohol. So second one is also called saponification. So alkali or base hydrolysis of ester is called saponification. Remember this point. So what is saponification means? Alkali hydrolysis or base hydrolysis of ester is called saponification. From esters, so we have two reactions. One is in acid medium and another is in alkaline medium. So esters on hydrolysis this is in presence of acid like HCl gives, or you can use dilute H2 soap also. Generally you are using dilute HCl or dilute H2SO4 ester or nitrobases in presence of acid like dilute HCl or dilute H2SO4 gives gives carboxylic acid. So example for this one is, before writing example, I am writing the general equation RC double bond O R dash plus H2O. So in presence of this H plus, it's a reversible reaction. The product formed is R C double bond O OH and R dash OH. It is carboxylic acid and this one is alcohol. Example CH3 C double bond O OC2H5. So this is ester. This one is ester. What about this one? This is also ester because RC double bond OR dash or OR also. So what's the name of this ester? First you have to name this group, attach it to oxygen, it's ethyl. And we know it's acetic acid, so it's ethyl acetate. It's a common name. IUPAC name is ethyl methanoate. Ethanoate. Okay, common is acetic acid acetate. So it is ethyl acetate. Ethyl acetate plus H2O in acid medium gives CH3 C double bond O OH and C2H5 OH. So it's a reversible reaction. And this is called acetic acid. This one is called ethanol or ethyl alcohol. Ethanol, this is acetic acid. Second example, you can write this example or complete at home. CH3 C double bond O OCH3. So you can complete this one at home.